Operating steam calendar rolls to maintain proper temperature profiles can be a real challenge. I'm Ed, and in this video we'll offer suggestions to improve your operations. To improve or troubleshoot problems with steam cans, it is suggested you review all elements of the steam supply, rotary joint, siphon pipe, and steam trap. Use the rule of thumb as a good estimate to calculate steam consumption of a steam can. We will discuss all of the considerations shown, which will have an impact on performance and also come into play if you wish to increase machine speeds or change the material being processed. As you increase steam pressure, you increase the temperature, which will improve the rate of heat transfer but reduce the quantity of BTUs available per pound of steam. As a starting point, use the rule of thumb to select a steam temperature about 20 to 30 degrees Fahrenheit above your required temperature. Then consult the steam table for the required pressure to meet this temperature. This will also provide you with the BTUs per pound of steam available. As the revolutions per minute of a can increase, the centrifugal force also increases, which changes the nature and position of the condensate formed. Can RPM will point to the proper selection of the rotary joint as well as the siphon arrangement best suited to meet your requirements. Higher speed systems due to siphon arrangements can also be more difficult to come off from a cold startup, so consideration should be given to drain the cans when cold. Knowing the can RPM as a function of machine speed is important, as mentioned, to determine the best way to drain the can. A tachometer is a good tool to check on this as well. A good method to measure can surface temperatures is an infrared gun. Be aware that infrared guns are not accurate when reading very bright reflective surfaces and read best on a black surface. For a stationary siphon, strive for the minimum clearance between the siphon pipe and the inside diameter of the can. The greater the gap, the more condensate which will not drain from the can, reducing heat transfer. Bent siphon pipes can be a challenge to keep clearance to a minimum, and using a siphon elbow can help alleviate this problem. Proper selection of a rotary joint is based on machine design and speed. We suggest consulting with your equipment supplier as well as rotary joint manufacturers. An important element is to ensure the steam supply and condensate return lines are connected to the rotary joint with flexible metal hose. Ensure that the hose has enough extra length to allow the rotary joint to move as it can turns. Not allowing the joint the ability to move will lead to premature failure. We also suggest you avoid using rubber hose due to the temperatures involved and the possibility of hose failure. We recommend you consider using a float and thermostatic trap which is able to deal with varying condensate loads, vent air on startup as well as during operation, and also discharge condensate as fast as it forms. We also suggest that the trap either have a manual internal steam lock release valve or external adjustable manual blow-through valve. The siphon pipe can lock up with steam when a trap closes or other internal factors which cause the trap to fail drain properly. The manual steam lock valve should be adjusted for a small amount of blow-through to ensure condensate flow at all times. Calendar rolls on a cold startup contain condensate and large volumes of air. One option to consider is to not shut down the machine for second or third shifts if the plant is not in operation, but rather consider dropping steam pressures to a point where the cans will drain but consume less steam by reducing radiation losses due to lower pressures and temperatures. Based on many years of troubleshooting problems, you can never have enough pressure gauges on steam supply and condensate return lines. Mark the gauges with a marker to show normal operating pressures, which can be of real help when troubleshooting. An infrared gun or camera is also a very valuable tool for troubleshooting. We can supply virtually all the products used on steam and condensate systems and can also locate hard-to-find equipment and parts. We can also provide instrumentation and controls to help manage your system, as well as providing technical help when needed. Thanks for watching our video.